Good morning, my dear students. Mr. Osama with you, science teacher. Let's start with lesson 3 in unit 2, radioactivity and the nuclear energy, the last lesson in this unit. Firstly, we have to review the atomic structure. As we know before, any atom consists of the central nucleus inside the atom. The central nucleus contains both positive protons and neutral neutrons. The positive protons and neutral neutrons concentrated in the nucleus have a large mass and considered the mass number of the atom. Surrounding the nucleus, the electrons which carrying a negative charge surrounds and revolve around the nucleus. This is the structure of any atom. As we know also, the number of negative electrons equal to the number of positive protons. That's why every atom has neutral charge due to the equivalence between the number of electrons and number of protons. The number of neutrons inside the nucleus differ from the number of protons or may be similar. What is the radioactivity? The French scientist Henri Becquerel discovered that the emission of invisible rays from uranium, the rays penetrated solid objects, and he called these rays a radioactive rays, and this phenomena called the radioactivity phenomena. What is the radioactivity phenomenon? Radioactivity is a spontaneous phenomenon whereby the nuclei of certain elements like uranium radiate different rays or particles. Therefore, the unstable atom can emit this energy and radiation. The radioactive atom emits radiation or energy or even particles, may called alpha particles and so on. The radioactive atom must be large atom which has large mass number due to the huge number of neutrons inside the nucleus. So this atom is radioactive or unstable atom. What are radioactive elements? Radioactive element is an element with an unstable nucleus. Unstable nucleus. This nucleus is unstable, so this nucleus may emit radiation or energy to become more stable. So radioactive element is an element with an unstable nucleus because the number of neutrons is higher than a certain number. Therefore, it radiates different radiations and gets converted to a stable element. We have two types of radioactivity, natural radioactivity and artificial radioactivity. Natural radioactivity without intervention of a human being, it's the radiation produced from radioactive element in nature. Examples of rocks of the earth. This type of radioactivity occurs in nature without the intervention of human. But artificial radioactivity is the radiation released during nuclear reaction in the nuclear reactor or nuclear bomb that made by human. So the artificial radioactivity made by human. Example of radioactive elements, we have to know this example, it's very important. Rubidium, selenium, yttrium, zirconium, strontium and uranium. These elements have radioactivity phenomenon, can emit radiations or energy due to their instability to form more stable nuclei. What are the uses of nuclear energy? The nucleus of each atom contains a huge amount of energy, what's called the binding energy of the components of the nucleus. As we know, the nucleus contains positive protons and neutral neutrons. These positive protons have repulsion force between the positive proton and the other positive proton. To overcome this repulsion force and make the nucleus as a one unit, there is a huge energy which is called binding energy to bind these components together, make a nucleus more powerful and stable. The nuclear energy inside the nucleus, we can use this type of energy in many peaceful purposes, like number one, a medical field, like a diagnosis and treat disease like cancer. We can diagnose cancer and treat cancer by using radiation from the radioactive element. Example of this that we have studied before, the cobalt-60. As you know, the cobalt-60 radiate gamma radiation which can kill cancer cells. Number two, the agriculture field, killing and elimination of pests and improve plants. We can kill pests by using radioactive element, by emitting the radiation which can kill pests. Number three, the industrial field, convert sand to silicon. By conversion of this sand to silicon sheets, we can use this silicon in manufacturing of computer processes, programmed electric circuits used in electric appliances, and finding defects in manufacturing products using a radioactive element. Also generating electricity by using a nuclear reactor. As we know that the source of electricity may be from a dynamo or electric generator which produce moderate or small amount of electricity. But here in nuclear reactor, the nuclear reactor releases large amount of electricity by using a nuclear reaction. The nuclear reaction releases large amount of energy which boil water, using this steam to turn the turbines and operate the electric generator, producing electric current and electricity. Number five, in space exploration, nuclear fuel powers rockets. Many rockets needs nuclear energy to reach space. Without nuclear energy, we cannot reach space by using rockets. Also, drilling for petroleum, oil, and underground water needs nuclear energy. The instruments and the machines used in these purposes needs nuclear energy. The harmful effects of radioactivity. Radioactivity has two sources, natural, as we know, and artificial. Natural, coming from rocks of the earth and cosmic radiation from the space. Artificial, the explosion of nuclear bomb or explosion of nuclear reactors. And an example, the most famous example, Chernobyl nuclear reactor in Russia that exploded in 1986. The explosion of Chernobyl nuclear reactor leads to, as you see, a cloud of nuclear radiations and components. This cloud moving to another place, making rains with the radiations. These rains affect the plants and affect animals feeding on these plants. The radiations inside the animals like cows and buffaloes reach the milk of the cows. This milk used by human, and the radiation penetrate the human tissues through the milk of the cows, and the plants reach in radiation. The effect of Chernobyl explosion was huge effect, 1986, occurs in Russia. The very harmful effect occurs in this area surrounding the nuclear reactor. This figure represents the Chernobyl disaster occurs in Russia, and this nuclear reactor exploded since this time. We have to know the radioactive isotopes. What are the isotopes? Isotopes are elements like this carbon, elements of the same element, or atoms of the same element. Isotopes are the atoms of the same element, like a carbon isotopes or hydrogen isotopes. The isotopes are atoms of the similar element which have similar number of protons, or the similar atomic number, and different number of neutrons, like carbon 12 and carbon 14. Here carbon 12 contains 6 neutrons, but carbon 14 contains 8 neutrons. Those atoms considered as isotopes of carbon. As the number of neutrons increases, the radioactivity of the element will be increases also. So there is a direct relation between a number of neutrons and the radioactivity of the element. The dangers of exposure to radiation. There are two types of exposure. Exposure of large doses of radiation for short time, which damages the digestive system, spleen, and the central nervous system. Also damages the bone marrow, which produces blood cells. These different types of damage reduces the number of red blood cells, and the person becomes sick due to these different types of damage. This is the first type, which is exposure to a large dose of radiation for a short time. The second type, exposure to a small doses of radiation for a long time, months or years, cause physical defects, genetic change in the sex chromosomes, result in abnormal birth, abnormality in the children, like this. Also cellular changes in the structure of the cell, such as the change in the structure of hemoglobin found in red blood cells. This change makes red blood cells incapable of carrying oxygen, leads to severe anemia. How can protect ourselves from the radiation? Avoid exposure to radiation. The maximum dose of radiation is 5 rem per day. The unit used to measure the radiation is called rem. So, if the number of the rems that reached our body exceed 5 per day, it will be harmful to the human. But the maximum dose, the maximum safe dose is 5 rem. Persons who handle radioactive elements in nuclear reactors and hospitals should wear protective gloves, suits, and masks like this figure. Also, storing radioactive waste, take the following precautions. Radioactive waste should be stored away from underground water resources to prevent their pollution. Also, radioactive wastes are stored in stable area away from volcanoes and earthquakes. Radioactive wastes are stored away from lands and caves to prevent the pollution from reaching animals. As you see here, the radioactive wastes put inside the ground, underground, in deep area, away from the water, underground water, away from volcanoes, away from earthquakes, and so on. Thank you very much for listening, and keep in touch through WhatsApp group to answer your question. Thank you everybody, and goodbye.